Yeah, good day and welcome to another exciting edition on our guide to professional audio engineering practices tips that we have been following. On this episode, which is tip 4, I'm going to be talking about analog and digital dichotomy. Now, by dichotomy, I'm going to what I mean is to analyze a division or a contrast that between analog and digital that are represented as being opposed or entirely different. So we're going to be looking at analog signal as different from digital signal. I'm not going to be talking about devices because most of us know they have analog device, analog mixers, processors, and all those things. But basically, what we mean by analog mixer are not entirely analog mixers. They are solid state electronics that handles analog signals. And the digital mixer that we are talking about is a cheap electronics that actually handle digital signals. So in this module, I'm going to be talking about the dichotomy between them and look a little bit in depth about the signals and how we get the best signals out of the two. So let me quickly go into a normal slide. Yes, okay. As you can see, I started talking about 3 different things here. The first one is to differentiate between analog and digital signals. And later talk about what actually determines the quality of analog signal, which is called analog inputting processes, and also what determines the quality of digital signals, which is called digital inputting processes. And without wasting much of the time, let's quickly go on. Now, I've talked about audio signal before, but let me just, in the first episode, which we call the fundamental of audio engineering, but let me just reiterate it here. Audio signals are of 2 kinds, 2 main kinds, either analog or digital. That is one thing. We all know that. But all audio signals begin and ends as analog signal or analog sound. Or do I call it sound wave? Don't let me use that word analog again because it will be a little bit confusing. All signals starts and ends with sound waves, even at the recording and playback ends. So digital sound can be thought as a kind of detour of analog sound through computational hardware. If you remember, in the fundamentals of audio, I mentioned that we deal with 3 kinds of sound signals. We are talking about sound waves, electrical signal, which is audio, and also digital signal, which is digital audio. And now we are talking about the digital sound or digital audio that we can be thought as a kind of detour, that is like a deviation of analog sound through computational hardware. That is what's telling us that there will be no digital signal without analog signal. That is what it means. Let's move on. So in analog recording, the waveform of the signal being processed, that is, we are talking about the sound wave of the signal being processed, resembled the waveform of the original sound. That is the beginning of analog. That means they are analogous. When something is a true representation of another thing, they resemble each other. They're analogous to each other. So the signal we call or we term as analog has its origin from sound wave that we capture through our microphone. So during that capturing, what we have captured is a true representation that resembles the original waveform from the source. That is why they say they are analogous to each other. So they are analog. For example, we can see that some of us may resemble one of our parents. Maybe as a man, as a boy, you resemble your father. They say you are analogous to your father. If you are a lady or a girl, you resemble your mom or your mother, you are analogous to your mother. So the same thing we are talking here is that the signal we are referring to as analog has its origin from the source, which is called sound wave. So when it's being converted to electrical signal, it has a true representation of the original. That is the reason why they are analogous to each other. That is what we call analog. It is the signal that we are calling analog signal, not the device. Only the signal pass through the signal through what? Through a signal flow is done from input to output. Now, digital. Digital audio is simply a signal or audio, in other words, that have been converted into a binary or digital binary formats. That's what I say is a kind of detour of analog sound. So it has its root from electrical signal, which is called audio or analog signal. That is one thing we need to know. So they say digital audio is simply a signal or audio in that word that have been converted into a binary format from analog signal. Now, what we mean by this digital audio has two parameters that determine its quality. One is sampling rate and resolution. Let us look at it. Sample rate and resolution are the two parameters that determine the quality of your digital audio input signals. That is what your digital device or let's say mixer is capable of doing at the conversion. So what is the sample rate? Refer to the number of samples an audio file carries per second. So from the analog signal that the digital device is sampling from, you understand now? So the sample rate that the device is able to sample from the audience percent is called what? It's called as in a sampling resolution, sampling rate. So why resolution or a bit depth it can be recorded by some textbook or by some books, dictate the amplitude resolution of audio file. So there are two things. You have the signal itself, and you also have what? The level. So there are two things that your digital device is actually capturing. One, the amount of quality that you wanted to capture within a second from that signal. Then in that signal, how qualitative the resolution of the amplitude is. It's what we call the bit depth or the resolution. Let me give an example of this sample rate and resolution. For example, 48 kilohertz. You know, most of our equipment will sample at 48 kilohertz. What does it mean? 48 kilohertz means that that device is sampling that audio or electrical signal 48,000 samples per second. So it's taking 48,000 samples per second out of what? Out of the original analog signal. That determines the sample, the rate at which the device is sampling what is actually taking the sample. And that 24-bit means that for each of the sample that have been taken, you know, I told that the 48,000 samples per second, for each of that sample that is being taken, 24 binary digits represent 1. That is the finest resolution. So that 24 binary digits will represent 1. We have 8 bits, we have 16 bits, we have 24 bits. Some even have 32 bits. In order to get the quality of what? Of the analog signal. So that is just the meaning of sample rate and resolution. So sample resolution, that is the number of bits per sample, determines how many gradation of amplitude, that is the level, corresponding to loudness, can be represented in a digital format. That is the reason why those two parameters are very, very important. And those two parameters determine how qualitative your digital mixer or your digital devices is or are. Let's go. Now, let us look at how does analog devices determines the quality of its input at this inputting process. Setting up your audio equipment to maximize the input signal and minimize the inherent noise is arguably the most important step in optimizing its quality. The first thing you have to know is that there must be signal to noise ratio. We are not talking about background noise. We are talking about inherent noise of the system. So there is a tendency for you, if you want to capture a very good signal, to actually maximize your input signal and minimize the inherent noise within the system. That is the first step in optimize what? The quality. There is this concept, the preamplifier, which is, maybe they call it gain control, of a mixing console or audio interface, which is the first stop for any signal entering the recording device or live sound system. For any signal entering your mixing console or your interface, the first stop for them is what? Is the preamplifier. So what is it? So a preamplifier or a preamp boosts the audio signal from low voltage level sources like microphone to a line level. If I have to go into that, that's another topic entirely. When you talk about levels in audio, we have low level, line level, loudspeaker level. I've created time to go into that some other day, another day. So whenever a preamp is employed, it is placed before the actual input of a mixing console or audio interface. The first interface of any signal entering into your mixing console is what? Is the preamplifier. So this is because you always want to record signals at line level. Now, the line level is the level that all our electronic equipment work with. The level that the microphone works with is so small that the mixing console cannot accommodate it. So it is the preamplifier that will bring that low level up to a line level that the mixing console and the rest of all audio equipment can work with. So they say it's because we always want to record signal at a line level, giving the audio device ample chance to record the healthy dynamic signal. That is it. And I would not just to tell you that what actually determines the quality of your mixing console, any mixing console ever, is the preamp. That is a talk for another day. It's the preamp. And how to determine that will be for another day. Let's go. Now, how do we determine the quality of signal entering your analog signal or analog inputting process? The first thing is gain. It's important to identify the crucial point here. Gain and volume are not the same thing, though can be confused in terms if the terms are used incorrectly. Let me just explain gain. Gain can be defined in several ways. So here, I will only refer to gain in the sense that it is commonly used. Gain is the amount of power increase in a signal and is almost always represented in terms of decibel. That is the reason why you have it on every channel of your mixing console. Gain, because it works with the preamplifier. The preamp will bring up the signal up to a level that the mixing console can work. But it is the gain that set the amount of power increase in a signal that is almost obtained by what? By in terms of decibel. What about volume? Volume is always the loudness, the final loudness, the level of your mix out that is going to the power amplifier that will drive the loudspeaker. That is the reason why you cannot find a gain knob on the output of what? Of your mix out, because there's no preamplifier there. I will stop like that. There, let's go. Now for digital input, how do you determine the digital input quality? Analog to digital converter. For every digital devices, there is this ADC converter. Now the ADC, or less commonly abbreviated as AD, analog to digital converter, is the analog to digital converter. Simply put, this is the crucial first step in a signal's input journey, where it transforms from an analog signal to a digital signal. And let me tell you this again, that what actually determines the quality of your digital mixer is the converter. And how many samples can your converter handles? That is, the signal is sampled by the converter so that it can be treated as a digital stream of audio data. That is the first contact. So an incoming signal before conversion exists as a continuous stream of varying voltage. Once treated by the ADC, it is converted into numerical representation of that varying voltage by the converter. We are talking about analog signal here, and cannot be considered as a complete digitized audio signal. So you will understand that most of the time, digital devices struggle to get quality signal input, while analog is just as simple as a representation of the original. So in conclusion, when it comes to the choice between digital audio and analog audio, it ultimately boils down to personal preference and specific requirements. Now, digital audio offers convenience, accuracy, and compatibility with modern technology, making it preferred choice for many applications. However, analog audio retains its own unique charm and sonic characteristics that resonate with audiophiles and those seeking a more organic listening experience. When you talk about analog, there is a true representation from the original. When you are talking about digital, it is a sample that have been taken from the original. And when you take a sample from the original, you still have something less. So you cannot compare, however your digital devices is, however expensive they are still dealing with what? With sample, not the original, not the full representation of what? Of the original. Now, digital technology is making things to be convenient for us. At a touch of a button, everything responds. But when it comes to, it makes our job to work to be easy. But in terms of operational procedure, analog technology has come to stay. But when you are talking about quality of signal, then analog signal cannot be compared with digital audio. That is it. Thank you very much for this. If you really wanted to know more about this and you want to register for our courses, then call on this number that is on your screen, and also you can tell us, if you are interested in what essay. And from there, you say, thank you very much until another day that we have another tip. Thank you very much, and God bless.